Welcome dear students to yet another session on residential space designing. Today you will learn a little more on light, its measurement and units used. You will observe terms related to light on a different dimension. Shall we start our journey? Light is that part of the electromagnetic spectrum which will stimulate a response in the receptors of the eye. Its frequency, usually expressed as wavelength, determines the color of light and its amplitude determines its intensity. Accommodation from the individual's part enables focusing of vision. Hence, the need to study lighting in interiors, especially when activities are carried out indoors. It is necessary to provide some sort of artificial illumination. In such circumstances, the designer should be aware of what lighting is provided and the satisfaction the user derives out of it. This is all the more important because a few major aspects decide active vision in human beings. What are they? Aspects which decide active vision are three, which decide exactly the method of vision that we have. They are electromagnetic spectrum, source of light, and the spectral sensitivity of the human eye. Electromagnetic spectrum considers light as two forms of energy, namely radiant energy and visible energy. Source distinguishes light from luminescent and incandescent bodies. Spectral sensitivity of the eye identifies eye's sensitivity to wavelengths of light and its adaptation to light. Let us see one by one. A recap on the visible spectrum will guide you better. Light is visually evaluated radiant energy, which is electromagnetic, which moves at a constant speed in vacuum. Have a look at the image. The entire radiant energy spectrum consists of waves of radiant energy that vary in wavelength of a wide range, an array of all rays, cosmic, gamma, UV, infrared, radar, X-rays, the visible spectrum, FM, TV and radio broadcast waves and power transmission. But what is visible spectrum? See the next image. The portion of the radiant energy which is seen as light identified as the spectrum visible to the human eye ranges from about 380 to 780 millimicrons, referred to as nanometers. A nanometer, nm, is a unit of wavelength equal to 10 to exponential 9 meters. What do these factors explain? Light can thus be thought of as the aspect of radiant energy that is visible. Color perception is attributed to the varying wavelengths noticeable within the spectrum of visible light. A mixture of most of the wavelengths within this range will give rise to a white light, but if any wavelengths predominate, the light will be colored. Thus, a colored light can be defined in terms of the intensity and wavelength of its components. Second one is sources of light. There are two sources from which light is received. One is from incandescent bodies, sources which are hot like the sun, bright luminous, natural or artificial flame, etc. And the other is luminescent bodies, which are cold sources, that is all the objects in the environment which reflect light. Sunlight is a simple thermal source and approximately 44% of sunlight energy reaching the ground is visible. The glowing solid particles in a flame are also common thermal light sources. Incandescent bulbs, another example, emits only 10% of the energy as visible light. The third one is spectral sensitivity of the human eye. How does the human eye act? What are the factors? except when looking directly at a light source. Sensations in the eye are caused by light reflected from the object in view. The human eye does not exhibit equal sensitivity to all wavelengths in the visible spectrum. The eye consists of cones and rod cells is a known fact, in which the cone cells are of three types. They are found to respond differently across the visible spectrum. The response peaks is somewhere around 555 nm. Naturally, visible light of uniform intensity from twin sources of light are found not to appear equally bright. The eye responds to light as a function of the wavelength. This concept is represented as luminosity function. In this context, the eye responds differently in different situations. It is called photopic vision when it adapts to light, that is, when the luminance levels are over 3 candela per square meter, and as scotopic vision when it adapts to dark conditions. Photopic response is the base for photometry. Hence, the brightness of sources in dim lighting predicted from the data obtained from such a method may not be reliable. Here, colors may not be that discernible. Photometry, or the measurement of light, is a method that assesses this. These units relate to luminous efficacy, a term used to explain raw power by a quantity. It is absolutely necessary to determine or arrive at sufficient illumination for various tasks in lighting of buildings, both in interiors and exteriors. These form the basics which decide measurement parameters of light. What are the methods used for measurement of light? Light is measured adopting two methods. Radiometry, which measures light power individually at all wavelengths, and photometry, which measures light based on wavelength weighted on par with a standardized model of perception of brightness by the human eye. They are the two sets of units popularly in practice to measure light. For quantifying lighting intended for human use, photometry, which measures only the visible light, is used. It considers human eye as a detector and gives data in multiple photometric units and measures. There is a factor representing the sensitivity of the eye to particular wavelengths. Photometry allots a weightage to the measured power to the individual wavelengths with that factor. Two aspects which guide us in measurement are propagation of light and parameters considered in photometry. What are they? Light propagates through three-dimensional spaces in many ways. It can spread out, concentrate, and or reflect off shiny surfaces. Similarly, light consists of different wavelengths. This attribute enables scientists to fundamentally measure different kinds of light in a broad range and also represent them in varied quantities and units. Photometry considers three aspects in measuring light. 1. The amount of meaningful light incident on a surface. 2. Quantum of light emitted by the source. And 3. The wavelengths with their specific colors associated with the light. Here lies the significance of luminosity function. You may wonder how and why. The answer is obvious. You have to remember one of the important aspects showcasing sensitivity of the eye is luminosity function, which considers perception of wavelength. How you relate it here is in photometry. In photometry, measurement of useful light always considers luminosity function. The unit used is the candela, from which all other units are derived. These points make us ponder about one important question very distinctly. What aspect of light are we measuring? Energy or brightness? Light is considered as a form of energy, and when it is measured as energy units, it becomes a physical unit. In applications where light is measured based on its brightness, they are explained in terms of subjective units such as candela, lux and the like. It is because of this subjective difference that light is described in multiple units. The word bright, usually used to refer to source of light, can be used as an adjective to refer to light in many ways. Why is this so very important? Ultimately, what is it? Let us learn more on brightness. A bright light is a source from which emerges a high density light output given in units of lumens, which channelizes and focuses the flux into a very narrow beam expressed as candela and focused against a dark background. Naturally, when considering the amount of light required in relation to the task being undertaken, it is the brightness of the object which is of importance. This brightness depends on the illumination and on the proportion of the incident light which the objects reflect. Brightness, scientifically speaking, is described in two terms, luminosity and luminance. How do these concepts differ? Luminosity defines the subjective characteristics of the visual sensation. They are influenced by various factors not directly related to the light reflected into the eye. Luminance or brightness refers to the quantity of reflected light measured photometrically. It is the amount of light per unit area reflected from or emitted by a surface per se that gets channelized within a given solid angle. It refers to light reflection which is measurable. How is it measured? Have a look at the table. This factor called luminance is measured in terms of a basic unit known as the Lambert and non-SI units. The Lambert is distinctly stated adopting the symbols L, LA or LB, proving that it is a non-SI unit of luminance. Contrarily, the SI unit of luminance is candela per square meter and the CGS unit is Stelb. Measurement of light in photometry. There are many concepts and terms that relate to the intensity of light. Each one has their own units of measurement as I explain here individually. First one is candela. Formerly called the candle, it is the international unit used to express an estimate of luminous intensity, specifically its denseness emitted from a source. Luminous intensity is the power of the light source. Second one is candle power. It is the unit used to express an estimation of the luminous intensity of a light source as expressed in candelas. Basically, it is considered a measure of the light produced by a bulb. Remember, it is the light measured at level of the bulb, not what falls on a medium. Measurement of the intensity of light is based on the concept of density of luminous flux flowing from a standard source of radiant energy which is arbitrary and is called the international or standard candle. The third one is luminous flux. It is defined as the amount of useful light emitted from the source, its light output. More specifically, it is the light energy in toto that a source emits across visible wavelengths of light. It relates to the time rate of flow of light measured in lumens. This refers to the flow of light related to a unit of solid angle. Evidently, it is the quantum of light that leaves the lamp. Fourth one is lumen. Lumen is considered as a photometric unit of light flow or light output. It is given as the term referring to the unit used for measuring luminous flux. The light emerging from a known point source of one candela, 12.57 lumens, falling on an area of 1 square foot space at a distance of 1 foot is 1 lumen. It is also given as equal to 1 foot candle falling on a surface of 1 foot square. It is the quantity of continuously generated light. Packs of an incandescent bulb emitting 60 watt and a compact fluorescent labeled 15 watt both indicate that they provide 900 lumens each. Therefore, this is a measurement of light versus area. If you look at the points given in this slide and the images in the next slide, you will understand the concepts better. Luminous intensity, the power of the light source, is measured in candela or candle. Light measured at level of the bulb is candle power. Amount of useful light emitted from the source, its light output, is luminous flux. Photometric unit of light flow or light output is lumen. Luminous power per area or illuminance is foot candle and lux. Look at the images. You will understand how each factor differs from the other and why we have so many terms and explanations. These leave us with some points to ponder. The light output of artificial lights is generally measured in lumens. Common trend is labeling light sources with an output rating in lumens, both initial and mean ratings. It is an indicator of the age or length of use of lamps and fixtures. In lumen output decreases. Lumen rating in lamps, how is it understood? There are two types of ratings. What are they? First one is initial rating. Lamps are rated based on the initial lumen, that is when they are new. It is an indicator of the amount of light produced by a lamp once it has stabilized. With use and age, the output tends to decrease. Second one is mean lumen rating. All lamps are expected to produce an average light output over its rated life. This factor takes into consideration a lamp's gradual deterioration in performance in the long run of its rated life. The initial lumen rating for a fluorescent lamp, even HID2, is 100 hours and its mean lumen rating is determined at 40% of rated life. So, after that period, one can expect the lamp's performance to be low. Labels on all packages will give you such necessary information. Students, have you understood where and how such information will be given to introduce the product to the consumer? Good. Till now, we have been dealing with luminous flux. Hope you understood the session till now. Let us continue further to comprehend the nuances of luminous intensity. Illuminance or luminous intensity. This is what happens when one uses light. It is something created by individuals. It is a quantum of light projected on a specific area and the degree to which objects kept in that surface get illuminated. It indicates the luminous power per area. It highlights the light received by the area. One measure of illuminance is a foot candle, while the SI unit it is lux. Let us try out an exercise. Turn on torchlight in a room at night. The flash of light falls where one has focused the torch. Objects falling on the focus of light get lighted. To be precise, they are illuminated. The person using the torch has lighted it up. This is called illuminance. An important word of caution is you should never confuse this with the quantum of light emitted by the source. Next aspect is the foot candle. And what is it? Considered as the basic unit of illumination, foot candle measures the amount of light falling on a surface. 1 foot candle is equal to 1 lumen distributed evenly over a 1 square foot area. In other words, it is the illuminance received on a specified area or object from a 1 candela light source placed at a distance of 1 foot. Advanced reading on the unit projects foot candles to demonstrate the actual amount of light from a source that falls directly on the object that is meant to be illuminated. It is the most popular explanation, comprehensible by all by its simple definition. For instance, a person buys a lamp where the label assures 100 foot candles of light. It is very clear then that a person sitting 1 foot away from the source will be able to receive 100 foot candles of light and therefore arrange things which need to be illuminated at that point. The person may increase or decrease the distance of the light source depending on one's requirements. So this unit is application specific and helps in designing lighting based on requirements. You can also try this out. Keep a standard candle at a distance of 1 foot from an angle. Measure the brightness. It will be approximately equal to 10.7639 lux. Finding out a fact on your own will make you wonder the role of the concept in space designing, right? Good. Let us become a little more knowledgeable about it. It is a commonly used unit in many fields and purposes like these. For control light levels to conserve light sensitive objects like paintings, photographs in museums and galleries, to calculate adequate lighting levels of workspaces either indoor or outdoor in the lighting industry, professional fields of photography, film industry, television, greenhouse, horticulture, structural engineering and in suggesting building codes. Lux is the next aspect. Having understood foot candles, focus your attention now to learn about the corresponding SI unit, namely lux. For this, knowledge on illumination is necessary. What is illumination? Have a look at the picture. People are not so interested in the total intensity of light given out by the source, but are concerned with the amount of light which falls upon an object. This phenomenon is known as illumination. It is defined in terms of lumens per square foot, that is, the luminous flux falling upon 1 square foot of area placed 1 foot distance from a standard candle, and it is equal to 1 by 12.57 or 1 by 4 pi r squared of the total luminous flux which is emitted by a standard candle. In CGS system, the equivalent unit is popularly called as lux, which is apparently 1 lumen per meter square. Have a look at the same picture again to further fine tune your understanding. Lux is an abbreviation for LM per square meter. Stated otherwise, 1 lumen per foot square is equal to 10.764 lux. Let me try to explain this better. Have a look at the second image. A standard candle or any wick is found to radiate light equally in all directions, that is in a circle. The output from the wick is not generally made to focus by use of reflecting devices, say a lens or a reflector. Imagine that the light makes a 1 meter radius sphere around the burning wick. It is a known fact that such a sphere encloses a 12.57 meter square surface area. 1 lumen is defined as the quantum of energy emerging from 1 square meter. Given the circumstances, if one tries to reduce the dimensions to represent a radius of 1 foot, the energy that is reflected from the source can be increased 12.57 times that of an energy which will fall on a 1 square meter area, right? I think based on these explanations, you are clear of the basic doubts now. Very good. Lux is used in photometry as a measure of the intensity after analyzing the way the human eye perceives it of light that strikes or traverses through a surface. It measures the incident light available at a known distance. It is a metric unit of foot candle. 1 lux is equal to 0.0929 foot candles. So, it is used to be called as a meter candle. Strictly speaking, the lumen measures the rate of flow of the luminous flux from the source, while candela describes the intensity of a light source in a given direction, specifically towards the eye, whether the source is an emitter or a surface which is reflecting incident luminous flux. These facts drive us to ponder on some interesting facts, mainly to know about a standard rule in lighting. If the light falling on an accessory at home is measured, one will observe that it is not directly proportional to the distance at which the accessory is placed from the source of light. Scientifically speaking, the lesson learnt is, closer the object is to a light source, say a bulb, brighter one finds the source as. This again can motivate you to do a self-exercise. Try it out. Collect photometric data of lamps from manufacturers or packaging labels. Using simple arithmetic, calculate illuminance for a specified area or room. To convert foot candles to lux, multiply foot candles by 10.76. To convert lux to foot candles, divide lux by 10.76. Probably knowing this calculation will tune you as a prudent consumer or practitioner in the designing process. Light measurement in the industry. Know about those units too. First one is Lambert. What is it? Lambert is defined as the brightness of a perfectly diffusing surface emitting 1 lumen per square centimeter or having an intensity of 1 by pi candela per square centimeter. In biological experiments, it is used in the form of a milli-Lambert or 1 by thousands of a Lambert. The unit gets a name after Johann Heinrich Lambert. 1 foot Lambert is equal to 1 by pi candela per square foot, which is equal to 1.076 milli-Lambert or 3.426 candela per square meter. 1 milli-Lambert is equal to 0.929 foot Lambert. Another unit is decalux. It is also a measure of luminance and is equal to 1.076 foot candles. Where is it used? It is commonly used for measuring luminance of images on a projection screen in the motion picture industry, measuring highlight brightness of visual display systems in flight simulations, but these facts are dependent on another factor called reflection factor. What is a reflection factor? The luminance of an object depends on the amount of the incident light which is reflected, measured as reflectance factor. All these units, dear students, are practically based on human vision as stated earlier and are therefore found to be useful in specifying safe and comfortable levels of illumination in a work area, may it be a house, office, factory or a commercial center, a primary field of activity for a space designer. Dear students, I hope by now you will also be clear about the terms and units used in light measurement. However, I feel you will appreciate a recap on them. Luminosity defines the subjective characteristics of the visual sensation. Luminance or brightness is light reflected from or emitted by a surface per se that gets channelized within a given solid angle. Candela measures the denseness of luminous intensity emitted from a source. Candle power basically is considered a measure of the light produced by a bulb. Luminous flux is a quantum of light that leaves the lamp. Lumen is a measurement of light versus area. Illuminance or luminous intensity is a quantum of light projected on a specific area. One measure of illuminance is the foot candle, while in SI units it is lux. Foot candle is the illuminance received on a specified area or object from a 1 candela light source placed at a distance of 1 foot. Lux is 1 lumen per square meter. Lumen measures the rate of flow of the luminous flux from the source, while candela describes the intensity of a light source in a given direction, specifically towards the eye. Lambert is defined as the brightness of a perfectly diffusing surface emitting 1 lumen per square centimeter. A word of caution is, always know the symbols used to refer to each unit. Obviously, a basic knowledge on photometry units in SI may be helpful in designing your space. Have a glance at the table. Luminous energy is given in lumens per second. Luminous flux or power is in lumen. Luminous intensity in candela. Luminance in candela per meter square. Illuminance and luminous emittance in lux. Luminous exposure in lux per second. Luminous energy density in lumen per second per cubic meter, and luminous efficiency in lumen per watt. You will definitely follow that each term used in explaining light is a quantity with specific meaning, and each such term is measured using exclusive units. A very broad field of study. Agree? Now let us study about the instruments used. Having understood the terms and units, let us see the instruments used for this purpose. Professionals in different fields are interested in photometric measurements specific to their disciplines. Measurements generally are based on photodetectors, switch type luminaires, light meters and the like. For complex measurements as needed in the lighting industry, spherical photometers are used. Tests on lamps and lighting fixtures are done by making use of gonio-photometers and or rotating type mirror photometers. A light meter is used to measure illuminance. It can show two parameters, namely the quantum of light incident on a given area and the quantum of light energy reflected off the surface itself. Use of a foot candle meter is in practice to determine the luminous intensity of a source. It resembles a type of photographic exposure meter. Have a look at the devices in the next slide. This session, I believe, my dear students, would have given you an insight on the concept of measurement of light, an indispensable element in everybody's life. Being bombarded with requirements of different kinds on one side and a sweeping array of options on the other, individuals find correct selection quite a difficult task. A little knowledge on these aspects covered today would help anybody, especially you, the future designers, to become prudent consumers. I wind up this session, and in the next, I'll introduce you to the sources of light and reflectance factor in detail.